You guys were able to actually finish the homework? Anyone actually, any of you guys stuck on anything? Wasn't able to do it?
So there's been...
Oh, the destroyed part?
Yeah.
Okay, I want to go over the answer to this too because I saw some things. Clark, you showed me one thing, but I also saw someone else email me too. I think Michael, you emailed me about how to do it, and yeah, this is actually really good. I'm really happy that you guys did. Some of you guys did it this way because I can show off some of the reasons why that's a bad idea.
Hey.
Yeah, it works. I know, but it won't actually, and I'll show you why.
But
Yeah.
Object-oriented programming way.
Yeah. No, just the non-crashing way. Just there's a way. Yeah, I'm going to show you guys. All right, and then so I asked for three things. One, to make the asteroids rotate, so they should rotate 45 to 90 degrees, and adding the concept of a medium asteroid, and when you blow up a medium-sized asteroid, create two small ones, and then make the asteroids have a collision with the player. Hopefully this works. When the player hits an asteroid, destroy the player's ship and print "you lose" to the screen. Now, destroying the player's ship wasn't really the difficult part. The tricky part was making it have this text. And so I actually have no collision on this right now. So let's go over the homework here. I think I have. So many things. So when we were in class, we went over how to make a large and a small asteroid. So I really just wanted you guys to make a version of the asteroid that was following the same pattern. So we made a large asteroid that spawned a smaller one. And I wanted you guys to basically follow the pattern of how we made that one and make a medium-sized one as well. Where is mine? That's the one I think I want. Pretty sure it was this one here. Game object CPP. Where is this? So, sorry, the first one is to make sure the asteroid rotate 45 to 90 degrees per second clockwise, or minus 45 to minus 90 degrees. So this is kind of an interesting one because you might have had asteroids that can rotate. However, I wanted you to rotate them at a very specific rate. And the idea here is I wanted some asteroids to rotate to the right and some asteroids to rotate to the left. And right now, I'll do that dark thing. All the asteroids are rotating in the same direction. This is actually just the solution to the homework. Let's see here. So there are actually several ways you could solve this problem. And if you see my asteroids here are rotating, I don't know if you can tell, they're all rotating clockwise. Okay, there we go. So some of the, like this guy here, he's rotating clockwise. This guy over here, he's rotating counterclockwise. And some of them are, they're all rotating at least around 45 degrees per second, and some of them are spinning slightly faster, and some of them are spinning slightly slower. I just want to have a random range, and I didn't want to just have the rotation rate be something that is like really slow. I want all of them rotate some certain amount. And so the way that I solve this problem, and this isn't the way that everyone has to solve it, is I added the concept of a rotation rate to the asteroid. And this is a member variable that is a number that represents how many degrees per second I want this asteroid to rotate. And all I'm going to do is inside of my update function for the asteroid, I'm just going to take the angle and I'm going to take this rotation rate, multiply it by dt, and add to it. So if I set this rotation rate to be something like 60 or 30, it'll rotate this asteroid by that many degrees per second. And so all you have to do in order to get the asteroid to rotate is, first thing is you want to generate a random number for this rotation rate between 45 and 90. So here, I'm generating a random number between 0 and 45, and I'm adding 45 to it. So this will give me a number between 45 to 90. And then what I do is I do this right here. So this is a one-line expression to 50% of the time reverse the direction of rotation rate to be either positive or negative. And let me break down exactly what this thing is doing. So it's taking the rotation rate and it's multiplying it by itself times some number. And this right here, do you guys see the question mark in here? This here is a one-line if-else-if statement, or if-else statement. Instead of writing an if-else statement all on separate lines, you can do it all on one line if your result is also in, for me, I use this one, my result is like a simple number. So what I'm doing here is that this right here is actually my condition for my if statement. And what this says is that if this condition is true, pick this number. Otherwise, pick this number if that condition is false. If I were to rewrite this using an if-else statement, it would be rand modulo 2 is equal to 0. Then I'd do m rotation rate equal to m rotation rate times negative 1, else like so. If I were to rewrite that, that's what it would look like here. It's exact same behavior. If this is true, do this. Otherwise, do this behavior. And this behavior is taking this rotation rate and is multiplying it by negative 1. And remember, you can use times equal to just have it multiply by negative 1. So if I want to shorten this expression. And the reason I do this is because typically I only want this thing to be one of two numbers. It's a very, very kind of straightforward expression. So I am combining it because this is actually something we do a lot, where you want to take the result of this if this is true. Otherwise, this is false. And it doesn't really matter the order of this. This can be a 1 or this can be negative 1. But ultimately, this means that now I get something that makes the asteroid spin 50% of the time. In positive direction, and 50% of the time, I flip the direction here. Okay? And that's really all it takes is specifying the rotation rate here to be a number first, and then flip it half the time. Okay? Any questions on that? Does that make sense? This is called the ternary operator. This little question mark guy right here. It's always a question mark and then a colon. And another common way you do this is when you have like a pointer to an object. So if I had like an asteroid pointer, like perfect example is this. So this asteroid pointer, if I had a float value for like, score to give equal to this. This is another good example of where you use the ternary operator. This means not equal to null. You test the pointer to see if it's valid, and if it's so, then you do this. Otherwise, you fall back to this. Another really common case of using a ternary operator. And we use this on Overwatch like all the time because we have things like, oh, get this, see if this thing exists, or see if this thing has a component on it, and if it does, then do this behavior, otherwise fall back. And it's just a really simple way to combine an if-else statement.
Keith, can you remind what dynamic cast is again?
Yeah, actually, we're going to go over more of it today, but I can talk about it at least now. So in this function here in collided with, do you guys remember when this thing gets called here? It gets called all the time for whenever you shoot a bullet, right? And it even gets called when you shoot yourself on the ship. So if I fire a bullet, so I fired a bullet, right? I actually just hit control to fire 3 bullets. And so the bullet here, this function gets called right here. So this is our collision loop that says, hey, see if this bullet is colliding with anything else in the game. And it happens to be colliding with this other thing. And what is this other thing that I'm passing into it? So this other thing here is a player. Now I know that it's a player because I just expanded it. I can click on this little guy to say like, oh, you can see it's a pointer to a player, right? And if you remember our hierarchy, I'm going to bust out paint here. We have game object here, right? This is our class hierarchy. And from game object, we have player. So a player is a type of game object, right? What else is a type of game object here? We have bullets. What's another type of game object here? Okay. What are other types of asteroids? We made them.
Large.
We made like, yeah, large, medium, and small. Small, medium, and large. So this is our hierarchy here. This is our tree. And so what we have here, though, if you look at this, we have a pointer. The argument that's passed to this function is a pointer to a game object. What this means is that this is a polymorphic type. It means that we don't know. This pointer to a game object can be any of these. It can be any of these things. That's what the game object pointer can represent. It can be pointing to any of these things. An asteroid, a player, a bullet, a small, medium, large asteroid. It can be any of those things. So how do we know which of these things it is? This pointer is polymorphic so that it doesn't, you don't necessarily know just by looking at this what it is. Like this logic here for this pointer, it could be an asteroid. It could be a player. It could be another bullet too. The problem is we want to change the behavior of the bullet based on what it hits, right? And so in order for us to do that, we need to figure out what thing it's pointing to. Now, the reason why this can be anything is that if you look here in the update function where I'm calling collided with, look what it's doing here. We have this array of game objects, right? This has 9 things in it right now. It has 9 of these things. So look here. Because it has 9 of these things, each of these things is actually a little bit different than the other. I'm just going to add them all. So looking at this, can you tell me what each of these things are? Looking at just the pointers like that? There's kind of no way to tell what they are. But C++ knows. Like it knows the type that it's pointing to. It knows that like 0 is going to be the player. This is actually the player object here. It knows that these are probably asteroids. Yeah, these are large asteroids here, large asteroids. But the reason why object-oriented programming is so strong is that I don't care what type of object it is. I just get a pointer to it. I'm just grabbing it right here. And then what I do is I call this function on it is colliding with. Because all game objects have this function in it. And then if I detect that this is true, if it is colliding with it, then I call this function here. Now this function is not on every game object. Only the bullet and the player have implemented this function. If you look here in the game objects, here's the game object. The collided with function doesn't do anything here, right? However, the same exact function is in the bullet here and in the player. So the bullet and the player have their own versions of this. But the code that calls those functions is exactly the same. This one line will figure out whether it should call the bullet version of it or the player version of it, right? And because of this, and look what I'm passing into it though, I'm just passing in other. I'm just passing in another pointer to a game object. So all dynamic cast does is it lets you figure out if this other thing is an asteroid or not. So dynamic cast will say, hey, try to turn whatever you are and see if you are a type of asteroid. It's asking, hey, I know that you're pointing to something. I don't know exactly what it is. So can you tell me if you are an asteroid or not? And if you are, if you're doing this dynamic cast, it will return you a pointer to that thing that is an asteroid. And that's why this if statement is here, because if this thing is a bullet, like it is now, like if you look here, this guy other is a player, right? So what's going to do is say, hey, player, are you a type of asteroid? And you can obviously tell from this hierarchy it's not, right? The only way it would actually be true is if player wasn't here. If I move player, and instead player was like right here. So if player was a type of asteroid for whatever reason, if we derive player from the asteroid class, then what we're doing here, which is this other pointer is actually a player, this would actually succeed and I would get back a pointer to an asteroid. However, because a player is not an asteroid, we get back nothing. This asteroid pointer says, nope, I can't turn you into an asteroid, so you turn into this value here, empty, all zeros. This is null. Which means this if statement isn't true, so it skips it. Which means, hey, a bullet collided with a player, I tried to turn it into an asteroid, player was not an asteroid, so I'm not going to destroy it. If we didn't have this here, what would happen? Like if I just deleted this, what's going to happen once I shoot?
Destroys everything.
Destroys everything, right? Including the player. So I just hit this, I have the same player object, it just calls destroy and tells the player to get destroyed. And there you go. Player's dead. So you can do other things though too. Like let's say this failed, right? Let's try to turn it into the player. I can do the same dynamic cast to try to turn this thing into a player too, right below it. And if it is the player, we can do something like that.
Goodbye. No, we never die.
So anytime that a bullet excuse me. Sorry, I'm feeling a little under the weather. Anytime, I'm just going to move this up for now. Anytime the bullet hits a player, I can just scale up the player sprite. So here, let's run this again. I'm going to shoot. So we already know that an asteroid is false, so this thing is not an asteroid, right? So we go down to here. Close. We try to turn it into a player. Ah, success. We actually have a pointer to a player now. So we were able to turn this thing, which was a pointer to a game object, into a pointer to a player. Which means now successfully I can say, hey, now I can take your sprite and I can scale you up. So I can just run it every time I shoot. I can set a scale to be 5. Or I can scale as so you can see that I can basically detect what type of game object it is and have the bullets do something when it hits it. Oops. We're going to solve that today too. Damn it. Oh my god.
Lovely.
Maybe it's too much to double it every time that it's hitting it, because it will collide with it every frame. So as long as it's inside the cylinder, it'll collide with it. So you can do that behavior too. You can do behavior like if it's a bullet, if it's another bullet that hit it, you can do the same thing. You can also say, hey, try to turn it into a bullet. If player or bullet So if it's a player or it's a bullet, I want to... Now, a bullet won't really collide with itself. I'm actually going to get rid of this player part, because I can't see anything. I don't know how many times I run into that. So it's fine normally, but when I do the multi-shot, which has all the bullets colliding with one another, the bullets are all hitting, right? So it has this behavior. So why dynamic cast is useful is that it lets you take something that is a generic function, collided with takes a game object. So if we were to add like a UFO, for instance, now we can also dynamic cast against that, right? We can also be more specific. What if we can only blow up large asteroids? We can do that too. If we make this thing only cast against large asteroids, that means that now I can only blow up large asteroids. So I shoot that out. Cool, that works. So I can still blow up large asteroids. Cool, but now I can't blow up the medium ones, right? And I could add more behavior here to be like medium asteroid. Right? Or small asteroid. So I can blow up all of them now. But now I'm testing against the specific asteroid type, and this is basically a lot of unnecessary work. If I'm casting, I can cast if it's one of these or one of these or one of these, or I can just see if it's any of those by casting to the parent. So this right here, all these three casts are exactly the same as me casting it just to see if it's an asteroid or not. So this is the exact same code, this is the exact same behavior. By looking if it's a large, medium, or small, I could have just done it in one line, but at least now I can shoot everything. But now it won't work if I try to shoot like a UFO or something. So this right here is the same as me doing this, except instead of doing a large asteroid, I just do it to the parent class.
Yeah, 'cause it points to all of them.
Yeah, it points to all of them. Right. Okay. So did I answer your question?
Yeah.
For dynamic cast? Okay. Medium asteroids. So medium asteroid's pretty straightforward. We had a large and a small one. Medium asteroid, you make a class, just like you did for a large asteroid, and call it medium. And then you have to implement this destroy function for the medium one. And all destroy is going to do is going to create small asteroids. The large asteroid, when it gets destroyed, creates medium asteroids. So it's the same exact loop for creating these asteroids. It just happens to be here. All right. Let me go to the last one, which is probably the trickiest one, which is how to detect if it's game over or not. So some of you guys might have done this, where inside here, for instance, you did if player is destroyed, right? You did something like this.
Yep.
And I'm just going to do standard cout. Cool. Let me get rid of my code that actually does the destroyed. This is me drawing text to screen. I'm just going to draw it on the console for now. Let me show you what happens. So on the left here, when I get destroyed, I start seeing that, right? Cool, game's still running and everything. But this is weird. So what happens when an object gets destroyed in our game? We delete it. We remove it from the list. We give back the memory that the player was using. What happens when we destroy an object? We do this right here. We call delete on it. Now, if you remember what happens with delete, it says, hey, I don't need this memory anymore. You can take it back, right? And this is actually a problem because if you actually ended up doing this if statement here on this player, this guy, we deleted him. This is the same as if you did this, like that. And then you immediately said his player is destroyed. We deleted the player, and you're checking to see if it's destroyed. Now, it's not blowing up right now. However, it's kind of a ticking time bomb, because if you ever try to do anything more to the player, like let's just say we try to call update on the player, watch what happens now. So what's going to happen here is I'm going to try to have the player do something after he's been deleted. And this is going to end badly.
It's gonna glitch it.
And my game crashes. Now, can anyone explain why my game crashed here? Why did it blow up here? Well, let's take a little inspection here as to what the player object actually looks like. Oh, that's weird. All these red warnings. It's very angry at me. Huh. Well, let's take a little deeper look here. Let's see what his position is. Okay. The owner. This is his position. Can you guys read that? 1.9 times 10 to the 18th. His owner is all D's. His sprite. His texture size here. What is the size of his texture? That's really weird. So watch what happens. I'm going to actually just do this. I'm going to do this. Breakpoint right here. Okay. All this can go away. So here's my player object. Can you guys see he looks pretty healthy? Like his position here is like 600 and 300, right? I'm going to delete him. What happened to that position? It went out of date. So now I'm going to ask to see if he's destroyed. What does destroyed actually do? It checks to see if this variable is true. So what is that variable? What is the value of that variable? Let's see. True? Are you sure? It's not. It's 221 right now, which happens to be more than 0. So yeah, it's true. He's destroyed. So the problem here is that you shouldn't really be accessing the player after he's been destroyed. So this right here is a really common problem, actually, that you run into with game development, is that you access an object that no longer exists, like a player or a bullet or an enemy. After it's been destroyed, you have this thing called a dangling pointer. This pointer object here, it's still pointing to some place in memory. If I look here, I'm going to show you guys what it looks like. I think I showed you guys this before, like how memory looks. I'm going to grab his memory address. So this right here is where the player data is. So this little like block of memory right here is like the player, which is cool and everything. And I'm going to get down to here. Oops, I didn't actually. I'm going to delete him and show you what that looks like after you call delete. So here's the memory for the player, right? And then I'm going to run this down to here. And then I'm going to call delete. So what happened to all that memory?
Just looks like a virus.
It all went to D, right?
Yeah.
Now you're trying to, that's what the player is. This is what the player has turned into. He's basically this mangled mess of memory. But you're going to try to do stuff to him. You're going to ask this guy if he's destroyed or not. The thing is, your pointer is still pointing to right here. It's still pointing to this memory. It's right here. It says that, well, this is what I'm pointing to. The pointer always stays the same. It's all a pointer is a memory location, right? The memory location hasn't changed at all. It's still in the same place. The data that's in that memory location, though, has completely gone away. So when you ask to see if it's destroyed, you're basically saying, like, well, go around here and tell me what number that is, right? So this is why this method doesn't work. This is why you don't want to do this. So the way that you actually want to do this is you want something else that is going to stay alive even after the player's been destroyed to handle the game over. So what I suggest is if you have a member variable that says, hey, game over, and then you add a way to set that member variable to true, I added this to the game class. And then what I do is in this game class, when this thing is game over, inside the draw function here, I just have a member variable that I have. And if that thing is true, go ahead and create your text and set the font and draw it here. This is inside the draw function. And then inside the player, when the player collides with an asteroid, I destroy the player, and I have this M-owner game over. This M-owner guy, he's actually, if you look here, right here, there's a pointer to the game. This is where the game over Boolean lives. So you can just say, hey, game, right here. Go ahead and mark it as game over now. This is going to be really important because this is how we're going to be handling lives and respawning as well. So if I run into this guy, M-owner is this guy right here. Let me close this big memory display. So I call this function, game over is going to get set to true right here. And then inside the draw function, I'm going to let draw. This is now true. I'm inside the game draw, which is getting called from here, inside the engine. And now it goes into here and draws this. Every frame it draws this, every time. Right, every time. Because this thing just stays true. And that's how I get that text to show up. All right, questions? Okay, this game class, this is also where we're going to put like how many lives you have, what level you're on. Also, we're going to have behavior here to respawn the player too. Okay. All right.